start, okay? Yeah. So Ashutosh, yeah.
Yes, sir.
Tell me about yourself.
Sir, myself Asutosh Kumar. I have completed my BTech from RGP Bhopal in 2023. Uh, my father is a government teacher, and my mother is housewife, and my younger siblings is currently doing BTech in computer science engineering.
Yeah. So like it's almost 7-8 months since you passed out. What were you doing so far?
Sir, after passing out, I started preparing for GATE and other competitive exam in the field of mechanical engineering. That's it.
Yeah, that's great actually. Uh, yeah. So why do you want to join HPCL?
Uh, Sir, since I from childhood whenever I see a petrol pump, I was curious about how the fuel is coming around, and after in coming to my BTech, I read about company. I read about HPCL and find out how refinery is going, and how is the distribution of fuel is going on. Therefore, I have interest in working in the field of refinery area. Therefore, I want to join HPCL.
Does HPCL has a refinery?
Yes, sir. Two refineries.
Where?
Sir, in one in Mumbai and one in Visakhapatnam, and other two that were in joint venture JV.
Correct, correct. So, HPCL is more on the distribution side than it is on, let's say, extraction or purification and those kind of things. Do you know who does the major extraction in India?
So ONGC.
Correct, ONGC. And any private player that you are aware of?
No, sir, not at all.
Okay, who is the private player in oil in India?
No, sir, I have no idea about that. Which
Okay, there
private
is a
player?
company, uh, a private company, and it's a big company, and it's majorly oil-based company. Are you aware of it?
No, sir.
Okay. ठीक है. Uh, it's Reliance actually. Okay. Do you know Reliance?
Okay, sir.
Yeah.
Yes, sir.
Good.
Yes, sir. I know Reliance.
Yeah. Yeah. So that's amazing actually.
Sorry, sir. I am not recalled it because one of my friend working in Reliance. I am not. Sorry,
That
sir.
yeah, exactly. That's great actually. So you know when oil is extracted from the ground, it's not exactly we don't directly get petrol and all. How do you know how exactly the purification process works?
Sir, I have not knowledge that much how is purification process work.
Mm-hmm.
But I only know that the crude oil that we get from well, that is not in the form of petrol or diesel. We in
Yeah, I
distillation
just
process.
told you that actually. Yeah. So I mean, my question is, how is it purified? Do you have any idea about it?
No, sir.
Okay, okay, so the short answer is they boil it and then condense it, at different temperatures. Some
Yes,
things
sir.
get condensed early, some things get condensed at the end. Yeah. So essentially, I was trying to ask you something related to condensation. So, we have condenser in a power plant, right?
Yes, sir.
Yeah. So what exactly does a condenser in a power plant does?
Sir, in heat exchanger, basically in condenser, we reject heat.
Mm-hmm.
In
Right.
we reject heat
Okay.
that we get from excess of when sorry, sir, I can explain it again. When steam after expansion, when steam sorry, sir. Sorry, sir. I am little bit confused because since it is my first time. After expansion of steam, when steam having some amount of heat, then we process it through, and its phase is mixed phase. That is, some amount of steam is dry and some is wet. Then we send it through condenser, where we convert it into liquid form. In that process, we reject heat
Yeah. So
in
why
the
do we
form of
convert it
metal.
into liquid form?
Sir, after that, we pump it into boiler again, and we don't
So
have any pump that works on uh, steam. Therefore, we convert into.
there are no compressors. Have you heard of compressors?
Yes, sir.
Yeah. So why don't we use compressors there? And instead, why do we convert it into liquid and then pump it up?
Sir, when we use compressor, first of all, it is costly as compared to pump, and other thing, in compressor we have to input a more amount of energy, that is waste of energy.
Correct, correct. So your answer is correct actually. For a same delta P, for a same pressure rise, a liquid pump is much more efficient than a compressor is. Right. That is right.
Ye- Yes, sir.
Yeah. So do you know what is viscosity, Ashutosh?
Sir, it is ability of fluid to resist to flow.
Correct. So like yes, you are right. I agree. So it's like a friction kind of thing. So can you give me
Yes,
some
sir.
example where friction essentially is helping us?
Sir, in walking,
Correct.
between our foot and ground.
Correct. Now give me an example where is viscosity is helping us.
Sir, sir, in lubricant,
In lubricant,
that
do you need viscosity in lubrication? Can you give me some
yeah,
example?
yes, sir.
Yeah, give me some example maybe.
Sir, in lubricant, as well as in sir, when we there is a more sorry, sir. When there is we in the functioning of
Okay,
machine.
Ashutosh, first think and then talk. Okay, just go
Sir,
on saying thing. Just
can I use English like
yeah,
that?
you can.
Okay. Yes, sir. Can you please repeat the question?
Yeah, so like, can you, yeah, and just like you say, lubricate. Okay, okay, I'll change the question. Let's say you are a designer. There is a pump in your refinery. You are working in HPCL right now. There is a pump, and you essentially want to procure some lubricant for it. Okay, so
Yes, sir.
what are the qualities of that lubricant that you would aspire for?
Sir, first I will check the viscosity.
Okay,
What is our desired
no,
viscosity?
no, no, no.
It is
You
low.
have to simply, tell it. Don't say what is our desired viscosity. It's same like you will be now going through the books. No, I want you to decide viscosity. Should it be less, more? Density, should it be less, more? I want you to think in that way.
Specific heat.
Mm-hmm.
Second point.
Okay.
Third point,
How many?
density.
See, don't tell me
Sir,
parameters. Okay, I want you
okay.
to tell me should the specific heat be higher or lower? Density
Okay.
should be higher or lower, something like that. You
Okay.
want to procure it,
Uh,
you want the
in
properties. Yes, please.
Okay. In pump, we have viscosity, that viscosity of the oil will should be low. There is another term called flash point and fire point, that should be high. And another point, that is uh, uh, flash point, fire point, specific heat, that should be higher, as much as high as possible.
Why the
And
specific
about
heat should be
densities,
higher?
sir, specific heat indicate that how much
I know
amount
what
of
it
heat.
indicates. Why should it be higher?
Sir, because of if a specific heat is high, then temperature rise of lubricant should be low.
Correct. Right. Yeah. No, that's it. So can you give me statement of second law of thermodynamics?
Second law of thermodynamics. Sir, currently I am not recalling because there are two clauses statement and Planck's statement.
Kelvin Planck statement, yes. Okay,
I am
that's
currently
okay.
not recalling
Yeah,
exactly.
that's okay.
Therefore,
So are these two statements different?
no, sir, both are same.
Both are same. Okay. So why do we have two different statements given then?
Sir, sir, it is the point of view of two different people. But ultimately, when we try to draw mathematically, then ultimately we find same conclusion. Both the statement saying about that.
Okay, great. So fine. So can you tell me second law of thermodynamics in terms of entropy?
Yeah, yes, sir. In mathematically, we can define delta S equal to delta Q by T. Where delta S equal to entropy, change in entropy. Delta Q is change in heat, and T is
Uh,
the absolute temperature.
again, tell me again, please.
Delta S equal to delta Q upon T.
Okay, is that correct? Think again.
Yes, sir. So, sir, it is valid. It is valid for reversible process.
Correct. So usually it should be greater equal to dq by dt.
Greater than equal to.
Correct. Now,
Sorry, sir.
there is a term that we bring in to make it equal.
Yes, sir.
Yeah, what do we call it?
Entropy generation.
Correct. And can you, tell me something about entropy generation?
Sir, entropy generation happen due to internal irreversibility. When system have internal irreversibility, then entropy generation come into picture.
Correct. So now, just a minute. Yeah. So imagine, I have maybe this rod. Okay, this is a rod, for example. I have a rod in my hand
Yes, sir.
and I heated it up. Okay, maybe at 100 degrees Celsius.
Yes, sir.
And the atmosphere is like maybe 25 degrees Celsius or something like that. And then I kept it in open air and it cooled down. What is the change in entropy of the rod? Let's say, don't give me very exact answer, but what will be the expression for change in entropy of the rod?
Sir, according to Clausius, I have to tell about entropy generation, or I have to say what will be entropy
No,
generation,
entropy. I'm
positive or
talking about
negative.
change in entropy of the rod.
Sir, change in entropy of the dot, if we go mathematically, then we should write it MCP ln T2 by T1, where T2 is the final temperature and T1 is initial temperature.
Correct. Now in this case, T2 will be less than T1.
Yes, sir.
Correct. Then the ln of that less than one value will be negative.
Yes, sir. Yes, sir.
Yes. So entropy change will be negative.
Negative.
Yeah. Now doesn't that violate the second law of thermodynamics?
Sir, sir, the second law thermodynamics is not particularly say about system. It tells about complete universe.
Okay.
So,
So in
our system having the entropy degradation, but overall universe having entropy, change in entropy will be positive over overall entropy.
okay.
Therefore,
That's correct. That's correct. Okay. So take an example. Let's say you have a cuboid and it is filled with water and completely filled with water.
yes, sir.
Okay. Now in case A, you are hitting the cuboid from the below. You are
Yes, sir.
hitting using a burner or something like that. And in case B, you are hitting it from above, its top surface,
Yes, sir. Yes, sir.
a burner.
Yes,
So
sir.
what will be the modes of heat transfer in case A and case B?
Sir, in case one mode of heat transfer will be radiation and convection.
Okay, forget radiation, please. There is no radiation. Forget radiation
Okay,
for now.
in case one, there will be heat transfer due to when the flame of the burner hits the bottom of the cube, then it will be transferred through conduction and convection.
Okay, see, ignore the bottom of the cube. Okay, it's imagine like you are just giving the heat directly to the water, something like that. It's a
Yes,
hypothetical.
yes,
You
yes,
don't need to. It doesn't need to reality. Point being, the water will get heated, right?
yes, sir.
Yeah. So the question is, in case A and in case B, what are the
Yes, sir.
modes of heat transfer? Okay, so
Sir, in
Bipasha
case
and
A,
Amiya. Okay, you also try this. You also try to think. I won't give the answer right away.
sir, in case one, heat will be transferred due to conduction and convection.
Okay,
But in case B, heat is transferred only due to conduction. There will be no convection.
why?
Sir, convection is mainly due to gravity.
Convection is due to gravity.
Sir, if I have a pen and paper, then I will
Yeah, please,
explain
please.
on.
Yes, yes. You don't have pen and paper?
No, sir, I have, but how can I show you?
Okay, you try. You just say it. I'll
Okay.
understand. Yeah.
Let me explain. Let me explain.
Okay, Bipasha. You answer the question, please.
So when we are heating from below, conduction and convection both will happen, and when we are heating from above, only conduction will happen, because in convection we need convection currents. Convection basically means macro form of heat transfer in fluid. जहाँ पे sorry हिंदी
Take it. That's okay.
convection convection
Uh,
basically means macro form of heat transfer. So that macro form of heat transfer is due to density difference. The part which gets heat up rises, and because of this movement, uh, convection takes place. So in
Okay.
second case, only conduction.
Yeah. That's correct. That's correct. Yeah. I think Ashutosh was on the same track actually. And
yes, sir.
yeah, it's
Sir,
more on the
sir, I
buoyancy
have.
Hi,
side
sir.
than gravity.
Let me say
Hello,
that.
sir.
Uh-huh.
Amir here, sir.
Yes, yes.
Actually, I joined here late, so I did not know the question. Pardon
That
me, sir.
yeah,
Sir,
I'll tell it to you later. Okay, don't worry.
Sure, sir. Sure,
Okay.
sir.
Sir, I have try to say same thing. Conduction is due to when density difference than molecule where if we यहाँ पर अगर हम हीट सप्लाई करेंगे तो ये जो मॉलिक्यूल है थोड़ा सा हीट आगे ट्रांसफर करेगी थोड़ा सा ऊपर जाएगी थोड़ा सा आगे ट्रांसफर करके थोड़ा ऊपर जाएगा इसकी वजह से कन्वेक्शन होगा बट ऊपर से अगर हीट ट्रांसफर करेंगे तो ऐसा कुछ नहीं होगा
ठीक. That's a good answer actually. Well done, Ashutosh and Bipasha. Okay, another question. There is a rod, okay, heated rod. It is placed in air. In case A, it is horizontal,
yes
and
sir
in case B, it is vertical. Okay, Anish, I forgot the name. Amiya, yes, Amiya. You also try, okay?
Yes, sir. Yes, sir.
Yeah. So there is a rod. It is heated. In case A, I kept it horizontal, and in case B, I kept it vertical. There are no air is flowing around. Okay, so it's perfectly, like natural convection kind of thing in both the cases. So, in which case you want to you have to comment about the heating of the rod, rate of cooling of the rod. In which case, if any, the rod will get cooled faster, and in both the cases, it will be the same cooling rate that one will get.
Sir, I think
रुक जाओ एक मिनट
vertical
सोच
one.
लो सोच लो थोड़ा.
Sir, I have don't know exact answer, but I have मतलब some कुछ बातें दिमाग में आ रही हैं. Can I?
हाँ एक मिनट अमिया
Sir,
रुक जाओ एक मिनट अमिया.
I think in the horizontal case, it will cool faster than that of a vertical.
ठीक है you go now आशुतोष.
सर सर यहाँ पर एक टर्म आती है हेजलर चार्ट हम लोग पढ़ते हैं हीट ट्रांसफर में.
ठीक है.
सर तो हेजलर चार्ट में क्या होता है ना कि सर जो टी लेते हैं थिकनेस ऑफ द स्लैब वो उसका थिकनेस लेते हैं. तो सर इन हॉरिजॉन्टल केस थिकनेस विल बी डी इन हेजलर चार्ट and in vertical it will be L. So
ओके.
characteristic thickness will be in higher in vertical rod. Therefore, cooling rate will be higher in mm,
So you,
vertical rate.
okay, fine. I mean, your answer is, although the answer is correct, the explanation is very advanced, I would say. Okay. Yeah. Bipasha?
So, according to me, since you're saying that air is not moving, that means it will be free convection. So I didn't think of Hpcl chart, but I thought of Nusselt number HLC by K, and Grashof number will also come in play. So the characteristic length will vary. In case of vertical rod, the characteristic length will be equal to the length of the rod. But in the horizontal one, the characteristic length will be equal to diameter. So it will cool faster in vertical one.
Yes. So answer is correct. Characteristic length approach is also correct, but can you, dumb it down a little bit? You are going too advanced. Okay.
Yes, sir. Sir, can you explain what is the exact explanation of this in our
Okay. So see,
layman terminology?
yeah. So for example, in case of a vertical rod, the air will get heated up and it will rise up. Okay. So essentially, the top of the rod, it is experiencing, although overall case is still natural convection, the top of the rod will experience forced convection. Okay.
Yes, sir.
Now, in
Yes,
case
sir.
of a horizontal rod, that is not the case. It's, free convection or natural convection everywhere. But in a vertical rod, air will rise up, and because of that, there will be some kind of velocities in the, upper portion. It will, rise up and like that. Yeah.
So can we
Yes.
say that stronger convection currents will be able to be formed up when it will be vertical?
Yeah, yeah, yeah. So, yes, you can say that. Overall, see that interview, HPCL interview is not that technical one. Okay. But I'm still, trying to uh, involve you a little bit into that. My point being, don't go too advanced into it. Many of the times, they are not much aware of these things. Okay.
Okay, sir.
The people over there are actually more on the practical side, so that's different story, but still, yes. Okay, Ashutosh, so let's uh, complete your interview here. So yeah, Ashutosh, I think you need to improve your introduction. Okay.
Yes,
So
sir.
yeah, number one, I would say don't, tell about, what your siblings and all are doing. So
Yes,
just
sir.
remove that. So you tell your name, your hometown, maybe what your mother, father does, and they do, and your BTech college. And after that, you need to add something related to maybe your internship or something like that, if you have any.
Yes, sir.
Okay, yeah, and you have a good technical overall capabilities. Okay, so I would, it won't be much wrong either to add at the end that, oh, these are my favorite subjects, something like that. Okay, if
Yes,
in
sir.
case you want to. Okay, I am not saying you should, but for example, when I had my chance, I always at the end I always go with my I am comfortable with, or my favorite subjects are fluid dynamics, heat transfer, and something like that. Reason being, I know, I don't want the interview to go here and there. I want it to be, directly to the technical, because if someone asks me technical, I know I'm good at it. So that way, but I'm not saying you should do that as well. I'm just telling you the last line of your introduction should be a little bit more designed way, so that, essentially the last line is something that, brings in your that starts the interview. Okay. Yeah, one more thing.
Yes, sir.
Your answer, I didn't touch the HR side today as such, just formal questions. So your
Yes, sir.
answer to
Yes, sir.
why HPCL isn't that great, to be honest. Okay, saying that I have been looking at petrol pumps and all, that's very abstract one. So try to think of a better one. If you can't, reach out to me and we will discuss and maybe come up with something better. Okay.
Yes, sir.
Okay. So give a thought. Yes, and also before answering, take time.
Yes, sir.
Okay, what you do is, I mean, I hope even Bipasha might have observed it as well. What you do is, you essentially, just तुम बोल देते हो, ठीक है? और
Yes,
फिर
sir. Yes,
बाद
sir.
में then you go ahead and then you recall, oh, maybe I should think, and then you come back and then you ask, oh sir, can I repeat, can I think again, like that. Take your time. Your English is not an issue. Okay, your Hindi is not an issue. Usually the interviews are both Hindi English, they don't really care. Point being, देखो क्या होता है ना, 10 से 15 मिनट हार्डली मिलते हैं। हाँ प्रथमेश, जस्ट एक मिनट प्लीज। 10 से 15 मिनट हार्डली मिलते हैं। अच्छा, ये जो मैं सजेशन दे रहा हूँ सबके लिए है। सो 10 से 15 मिनट हार्डली मिलते हैं, तो ट्राई टू बी वेरी कंसाइज, ट्राई टू बी वेरी प्रिसाइज। ओके, साउंड्स गुड।
Yes, sir.
हाँ हाँ प्रथमेश, क्या बोल रहे थे?
सर अभी इंटरव्यू लेने वाले क्या आप?
हाँ ले लेंगे, आप बताइए।
ओके सर।
ठीक,
यस सर, चलेगा।
चलो, ठीक है। ठीक है आशुतोष, सो या I told you 3 points. Improve on that. Your
Yes, sir.
introduction, why HPCL, and your
Yes, sir.
fluency, and think before you speak. Yeah.
Yes.
So Bipasha, you want to join in,
Thank you,
or
sir.
you want
Yes,
to
sir.
do it later?
No, no, sir. Right now.
Okay, yeah, please. Okay, great. Yeah, so hi. Okay, यार problem ये है, एक मिनट।